Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Idham Hakimi bin Cik Rusoh. My metric number is CN200260. My supervisor is TS Dr. Khairu bin Kamarudin. My project title is Characterization of Honey Bamboo Biochar and Wood Liquor based on various burning parameter. Gantt chart of PSM1. PSM Talk Series 1, 2 and 3. I attend on week 1, 2 and 3. Supervisor selection on week 1. Project title on week 1 and week 2. Proposal project on week 2. Proposal submission at SMAP on week 3. Draft chapter 1 introduction on week 3 until week 5. Draft chapter 2 literature review on week 3 until week 12. Draft chapter 3 methodology week 5 until week 12. Site visit to UTHM Bamboo Farm at week 9. Submission draft PSM1 to supervisor on week 12 until week 14. Correction draft chapter 1, 2 and 3 on week 13 and 14. PSM1 writing report, presentation slide and video on week 13 and 14. PSM1 submission writing report, presentation slide and video at author on week 14. And last, PSM1 Q&A session on week 15. Introduction. Background of study. Biochar is a solid material made to the pyrolysis of biomass, which can include plant remains or waste from agriculture. Biochar is produced through a process called pyrolysis, which involves heating the biomass without oxygen. Biochar is a rich carbon source because it is produced by a method that locks in the carbon already existing in the biomass. Wood liquor, also referred to simply as wood vinegar or pyroligneous acid, is a liquid byproduct of wood pyrolysis. It is produced when the wood gets heated in the absence of oxygen, resulting in the release of volatile organic compounds (VOC) from the woods, and the condensed liquid resulting from the process is known as wood liquor. Pyrolysis is a thermal decomposition process that converts organic material. The process parameter for pyrolysis can vary depending on the specific application and type of feedstock being processed, which is temperature, residence time, and feedstock size and composition. For the objective of the study are related to the issue. Here are lists of some of the objectives that need to be accomplished in the study. To study the effect of various pyrolysis parameters on a mini-scale pyrolysis burner using honey bamboo. To characterize the physical of particle size, density and porosity, while chemical properties, element, composition and pH level of biochar and wood liquor produced using honey bamboo. For the scope of the study is to investigate using honey bamboo as a feedstock to produce biochar and wood liquor. The production process involves heating honey bamboo to various pyrolysis parameters, which is fast and slow pyrolysis in the absence of oxygen to produce biochar and wood liquor. The method used to characterize the physical properties of particle size, porosity and density using a scanning electron microscope, which is SEM, and gravimetric analysis or volumetric measurement method. Last, the characteristic of chemical properties on the element composition and pH level of produced biochar and wood liquor using the elemental analyzer and ultimate analysis. For the problem statement, first, the need for sustainable and efficient parameter of produce honey bamboo biochar. Second, to find the optimal burning parameter to producing high quality biochar and wood liquor. Third, lack of understanding are the characteristic of honey bamboo biochar and wood liquor under different burning parameter. Significance of study. The study of the characteristic of honey bamboo biochar and wood liquor based on the various burning parameter is important for several different reasons. This research help identify the ideal production condition for honey bamboo biochar and wood liquor by analyzing the effect of burning parameter on their qualities and composition. This encourage the use of biochar as a soil additive for improved soil health and crop yield, which in turn lead to more sustainable for farming method. The research fill up some of the gap in our understanding of honey bamboo biochar and wood liquor. This study provide information regarding the characteristic and composition of biochar and wood liquor by analyzing the way their properties change according to burning parameters such as temperature, heating rate, and time. The study also has relevant for recycling and resource conversion. Bamboo biomass is a quite plentiful and renewable, and it can process into useful product like biochar and wood liquor. This research assists in the development of effective and sustainable method for utilizing bamboo biomass by characterizing the biochar and wood liquor produced during the burning process. Chapter 2, Literature Review. For the feedstock, bamboo with the potential to grow on wasteland has emerged as the most appropriate alternative to wood. Bamboo is a perfect starting material for synthesizing biochar and activated carbon, high biomass yield, and significantly accelerated growth rate. Bamboo is superior to wood in all ways, including strength, environmental friendliness, water resistant, cost, soil protection, and contribute to air quality. Second, moisture content. The average moisture content was 34.44% on the bottom of bamboo, 25.89% on the middle bamboo, and 14.89% on the upper bamboo, where the upper segment of bamboo have met ISO 22157 standards. Measure of water content to be justified, determined, and proper level sustainable in a processing environment. Water content of sample material is then referred to a moisture content in the testing and evaluation process of moisture analysis. Third, biochar. Biochar is a far more efficient at converting carbon into a stable form and is cleaner than other form of charcoal. It looks like a lot common charcoal. Biochar is produced using a specific process to reduce contamination and safely store carbon. In terms of physical attributes, biochar is black, high porous, lightweight, fine grained, and has a large surface area. For the wood liquor or bamboo vinegar. Bamboo vinegar is a natural liquid derived from a condensed vapor produced during bamboo charcoal production. Bamboo vinegar is a reddish brown light liquid obtained by condensing the water volatile organic released during bamboo pyrolysis. It is composed of water 80 to 90%, acetic acid, and many more organic continuous, and has a sour and smoky odor. Pyrolysis process. The term pyrolysis refers to the non-oxygen thermal breakdown of organic molecule at the temperature around 200 degrees Celsius and 900 degrees Celsius. During pyrolysis, the molecules are subjected to very high temperatures, leading to very high molecular vibration at which the molecules are stretched and scanned to such an extent that they start breaking down into smaller molecules. Pyrolysis also is always the first step in other processes such as gasification and combustion, where partial or total oxidation of the treated material occur. Classification of pyrolysis process for the slow, intermediate, fast and flash pyrolysis, which property of heating rate, feed size, reaction temperature, vapor residence time, feed water content, bio-oil yield, biochar yield and gas yield. Thermal process depending on amount of reacting oxygen in the process. First, torrefaction. Second, pyrolysis. Third, gasification. And last, combustion. Chapter 3, methodology. Flowchart of methodology. Start, research background, literature review, methodology, result and analysis, conclusion, end. The flowchart methodology for a bachelor's degree project 1 involve identifying the research topic, conducting a literature review, formulating the hypothesis, selecting a research method, determining data collection method, developing instruments, organizing and pre-processing data, analyzing it using statistical or qualitative technique, drawing conclusion, and providing recommendation for future research. The findings are communicated to a written report and presentation, seeking a feedback to refine and improve the project before submission. Flowchart of methodology for the process, biochar and wood liquor. The pyrolysis process involves several key steps, including feedstock preparation, heat application, primary pyrolysis, then thermal decomposition. The feedstock is collected, sorted, and dried, and loaded into a sealed reactor vessel. The temperature is controlled, and primary pyrolysis occur, resulting in the separation of gas, bio-oil recovery, and solid residue removal. The generated heat or gases are used for energy recovery, and parameters are monitored and controlled. Waste management practice ensure environmental compliance. The flowchart provide a comprehensive visualization of the steps involved in the pyrolysis process, enabling efficient and controlled production of valuable product from biomass or organic material. Start, collecting honey bamboo feedstock, moisture content, pyrolysis method, which is slow pyrolysis and or fast pyrolysis. After pyrolysis process, is there the biochar and wood liquor successfully produced? If no, back to the pyrolysis method, and if yes, continue to data analysis, result and discussion, last end. For the objective 1, at pyrolysis method, which is slow and fast pyrolysis, and for objective 2, for the result, is the biochar and wood liquor successfully produced. Honey bamboo pyrolysis process for mini-scale burner. The honey bamboo pyrolysis process for a mini-scale burner involve the controlled thermal decomposition of honey bamboo biomass to produce biochar and wood liquor. This process harness the heat generated by the combustion of honey bamboo to initiate a chemical transformation that yield valuable byproduct for various application in agriculture, energy production, and environmental remediation. In the mini-scale burner, the honey bamboo biomass is loaded into the in a combustion chamber or reactor. The reactor is designed to provide control environment with a limited oxygen supply to facilitate pyrolysis rather than complex combustion. The biomass is heated gradually and the pyrolysis process begin as the temperature reach the desired range. Characterization of honey bamboo biochar and wood liquor. Biochar and wood liquor properties can be analyzed for physical traits like particle size, density, and porosity, affecting water holding capacity and nutrient retention. Chemical analysis help identify element and pH level, while microscopic study surface area and pore distribution. Overall, characterization help understand the unique properties and potential use of this material. For characterize of physical properties, first, particle size characterization involve preparing a material sample, observing its under SEM, and analyzing high resolution image to measure individual particle dimension. Image analysis software quantifies such distribution parameter. Porosity characterization involve preparing a material sample, analyzing it through gravimetric analysis or volumetric measurement, determining its porosity through liquid displacement. Density characterization involve preparing a material sample, conduction gravity analysis, and calculating density by dividing mass by volume. Technique like gas cyanometry and Archimedes principle can be used. Characteristic of chemical properties. Element analyzer analyze biochar and wood liquors element composition using high temperature combustion and gas measurement, providing valuable information for chemical properties and application. pH level analysis of biochar and wood liquor involve measuring the acidity or alkalinity of the solution, revealing potential effect on soil and water environment. Ultimate analysis determines biochar and wood liquor element composition using high temperature combustion and gas chromatography or mass spectrometry technique. Chapter 4, Expected result. Effect of various pyrolysis parameter on a mini-scale pyrolysis burner using honey bamboo. The study suggested that pyrolysis temperature affected biochar properties, with high temperature resulting in a high carbon content, reduced volatile matter, and stability, while lower temperature may produce high volatile matter and different chemical composition. The study examined pyrolysis time duration impact on honey bamboo biochar and wood liquor properties, aiming to determine optimal duration of ancient accessibility and nutrient retention in honey bamboo derived product. Characterize of the physical and chemical properties of biochar and wood liquor using honey bamboo. Analyzing particle size, porosity and density in a biochar and wood liquor sample is crucial for understanding their structure, attribute, and sustainability for various applications in agriculture, environmental remediation, and energy production. These properties reveal important information about the material compactness and bulkiness. The analysis aim to determine particle size distribution, density and porosity of honey bamboo biochar, influencing factor like water holding capacity, ease of handling, and aeration properties. Porosity analysis will reveal the presence and distribution of pores, affecting water retention, air retention, and soil nutrition retention. Chapter 5, Conclusion. In conclusion, the study on the characterization of honey bamboo biochar and wood liquor based on various burning parameters has yielded significant results. The examination of chemical properties such as element composition and pH level help determine their nutrient content and impact on soil fertility. Honey bamboo, biochar, and wood liquor have the potential to improve soil fertility, enhance crop yield, and contribute to carbon sequestration. That's all from me. Thank you.